Humans have a lot of paired organs. 2 eyes, 2 ears, and we understand why those come in pairs. But nostrils are different. They're close together, and our sense of smell isn't even that strong. So by the end of this video, you'll see why having 2 nostrils matters far more than it seems. Let's start with what feels obvious. Nature usually doesn't duplicate organs without a reason. 2 eyes give us depth perception. 2 ears help us locate the direction of sound. That logic makes sense. But when it comes to nostrils, it feels unnecessary. The smells don't seem different. The distance between them is tiny. At first glance, it looks like one of them could be redundant. But that assumption turns out to be wrong. Here's a fact most people don't know. Your nostrils don't work equally. Throughout the day, one nostril is always more open than the other. Air flows more easily through one side, while the other works less efficiently. This dominant nostril switches over time. At first, that sounds like a flaw. Why would the body design a system that never works evenly? But this imbalance is exactly what makes the system effective. To understand why, we need to look at how smell actually works. Smelling something doesn't happen in the nose itself. It happens in the brain. Odor molecules must travel through the nasal passages and reach the olfactory center in the cerebral cortex. Along the way, those molecules interact with mucus and epithelial tissue. And this is the key point. Different molecules are absorbed at different speeds. Some are captured very quickly, others move more slowly. One single airflow speed would fail to detect them all. This is where having 2 nostrils becomes essential. The more open nostril helps fast-absorbing molecules reach receptors before they disperse. The less active nostril slows airflow, giving slower molecules enough time to interact with the olfactory receptors instead of rushing straight into the lungs. Together, the brain receives a richer chemical signal. We detect a wider range of smells even though we're not consciously aware of it. But that's not the only advantage. Researchers at Berkeley wanted to test something further. Can humans orient themselves using smell like animals do? In their experiments, participants were blindfolded and had their hearing blocked. They were then placed on a lawn where a thin trail of scented oil had been laid out. Out of 32 participants, 21 were able to follow the scent trail correctly. This suggested that humans have a limited form of stereo smelling. To understand how this works, scientists visualized airflow patterns. They discovered that the regions processed by each nostril are separated by an average of about 3.5 centimeters. That distance is enough for the brain to compare signals from both sides. Just like with hearing, the brain can detect slight differences and infer the direction of a smell. In animals that rely heavily on scent, this ability is even more pronounced. Take moles, for example. American biologists observed how moles searched for food in controlled environments. With both nostrils open, they found their target quickly and accurately. When one nostril was blocked, the animals became slower, and their search path shifted about 20 degrees toward the open nostril. Even a small loss of symmetry disrupted their sense of direction. Here's the takeaway. 2 nostrils are not a backup system. They're not an evolutionary accident. They form a mechanism that expands our sense of smell and helps us orient in space. What looks redundant actually increases how much information the brain receives. So yes, both nostrils matter, even if you're not a mole. And that's baby science for you.